let's provide answer to this question. This is under logarithm. So we have log x base 3 plus log 3 base x equals to 10 out of 3. So we know if this were to have the same base, we'll have employed the property of multiplication, whereby we multiply the argument. Okay, but here we are having different bases, so we need to have a change of base. So here we can rewrite log 3 base x to have the base to be 3. So in this case, we can have log 3 base x to be equals to 1 over log x base 3. We are changing the base from x to 3, changing their position. The argument from here is 3, it is now x. So we have the same base 3 as a change of base. So now, since this is now going to be written as log of x base 3 plus 1 out of log x base 3 equals to 10 out of 3. Now we have the same base, but we are having a fraction. So now let's do substitution. So let your log x base 3 equals to, let me use y, so that whenever I see log x base 3, I'm having y plus 1 out of y equals to 10 out of 3. So this becomes an equation that involves one variable. We can see that y is a denominator, 3 is a denominator. So our LCM is going to be 3y, meaning multiplying both sides by what? The 3y. So now multiplying through by the 3y will now be 3y multiplying y plus 3y multiplying 1 over y equals to 3y multiplying 10 out of 4, 3. So this will be 3y times y, will be 3y squared. So we're having 3y squared plus y as a denominator can cancel the y in with the 3. So I'll be left with 3 times 1, that'll be 3. Here the 3 will also cancel the 3 since the denominator and numerators. That become y times what? 10. This is equals to. So what do? Now we are having y to the power of 2, y to the power of 1, and a constant. We can rewrite this as an equation which is quadratic equation. So we're having 3y squared, then that will be minus 10y, 3 is already here, equals what? 0. So now we're looking for factors of 3 times 3, which will be 9. When you add, you get a negative what? 10. You know the factors of 9 that can give us a negative 10 will be, both must be negative. So that when I multiply, I get a positive 9. So let's say 9 times 1 will be 1. But if I make the negative, that will have been negative 9 plus negative 1. That will give us a negative 10. So this is going to be in these two brackets. So we're having my y minus 10 and minus 9. Then y minus 1. But because you're using the 3 to multiply, you divide by what? 3. So in this case, y minus 3, as in this divided by this, will give us 3. Then y minus what? 1 out of 3 equals 0. So we are equating both brackets to 0. So this is going to be y minus 3 equals 0. That will give us y equals 3. Or this also equals 0 will make y to become what? 1 out of 3. So y is either this or this. But don't forget that our y is equals to log, we have it here, log x base 3. So that's substitution, taking the first y to be 3. So if y equals to 3, it implies that log x base 3 must equals to what? 3. You know, from indices connection with what? Logarithm, we can have the base taking the 3 as an exponent equals to the argument. So this will carry this, so become 3 exponent 3 equals to x, and we know 3 exponent 3 is 27, so it means your x is just what? 27. Then in the second vein, if our y is equals to 1 out of 3, that's as we have from here, then that is going to imply that log x base 3 must equals to 1 out of 3. Then with the connection of indices, 3 will take the exponent 1 out of 3 equals to the argument. So 3 exponent 1 out of 3 equals to what? X. We know this is also a cube root. So this could also be x equals to the cube root of what? 3. So in this case, knowing very well that therefore your x will either be 27 or cube root of what? 3. So that is the values of x that satisfy that expression, that logarithm word equation. Alright, thank you for watching. Like, share, and comment. Bye bye.